Alright, so here's an example of how to do some graph problems with density. So this first question here, we've got a mass versus volume graph where 5 samples of the same material measured, and then a line of best fit was drawn, and we want to determine the density of this material. Well, density is mass over volume, right? Density is the ratio of the mass per unit volume of material. And as we can see, that ratio is constant. We get a nice linear regression, a direct relationship between mass and volume, which is true of all materials since density is a characteristic physical property. So to determine this density, we are going to calculate the slope, because slope is the change in the y-axis over the change in the x-axis, and we can see our y-axis is mass and our x-axis is volume, so we can use the slope to determine the density. Now we got to find 2 points that have nice intersections on our line. Now I believe like this one right here is a real good intersection. The graph paper is a little light, and then I think there's one right up here. That's pretty good. Yeah, I think that one's really good too. Those 2 points. So this point, its y is right there, that's 7, and its x is here, that's 2. This one, its y is right here. We got 8, 1, 2, 3, 4, 5 spaces for 2. So 2 divided by 5. Each space is 0.4. So that's going to be 8.4, 8.8, 9.2. 9.6. So this is 9.6. And then over here, that's 1. That's 34. So I'm going to do that work right up here. So y2 minus y1 over x2 minus x1. These are my top ones are the 2's, the bottom ones are the 1's. So I've got 34 minus 7 over 9.6 minus 2. 9.6 minus 2. So we're going to plug all that in here, parenthesis, 34 minus 7 divided by parenthesis 9.6 minus 2. Whoop. 6 minus 2. Look good. Yep. Enter. Bump. 3.555. So we want to round that to the appropriate number of significant digits. So this actually only has 2 significant digits on that line. So, well, it's 1 decimal place, so we'd keep a decimal there. So at the top, we would have kept a decimal. So we'd end up with 3 digits. And at the bottom, these go out to 0, 0. It says they know, but we're going to say 3.55 then. So that equals 3.55, and it's the y units mass, which is grams, over x units centimeters cubed. 3.55 grams per centimeter cubed. All right, that's one question about graphing here. Now the next question on this asks, using the graph, determine the mass of a 2 centimeter cubed piece of the material. Well, we already done that actually. So we look for the volume of 2. We follow that up to the density line and follow it over to figure out its mass. And so that's 7.0 grams. that pretty simple because I already done it for my slope. Then the next question asks, let's zoom out so we can see more. Using the graph, determine the volume of a 27-gram piece of material. So here we follow this up. There's 25, 26, 27. Each line here is worth 1, 27. Follow that over to the line. That's right there. Follow that down to here. Now remember, we figured out earlier that each of these little lines on the x-axis is equal to 0.4 grams. So that's 6.4, 6.8, 7.2, 7.6, 7.6 centimeters cubed. Centimeters cubed. So that's our answer down here. 7.6 centimeters cubed. All right, then there's one more question here with the graph. Using the density that we found up above, 3.55 grams per centimeter cubed, determine the mass of a 15 centimeter cubed piece of material. So the reason we have to use the density is because our volume on this graph only goes up to 12. It does not go up to 15. So now we know that density is equal to mass divided by volume. And this wants me to find the mass. So I have to isolate the mass from this equation. So I want it all by itself. Well, it's combined with the volume here on the bottom. So I'm going to multiply both sides by volume. Multiply by volume. Multiply by volume. On the right side, the volume on the top and the volume on the bottom reduced to 1, so they essentially can be canceled out. And we got on the left side volume times density. So rearranging this equation, I would get that mass is equal to volume times density. And we can see that the units are going to work out there. So I take that volume of 15 centimeters cubed. I'm going to multiply that by the density of 3.55 grams per centimeter cubed. And that's over 1. I got a centimeter cubed on the bottom, a centimeter cubed on the top. I'm left with grams on the top. That's a good indication. If I didn't have that, it would definitely be wrong. Now that I do have that, there's a good chance I'm right, but it doesn't guarantee it. So grams on top, that could definitely be mass. So I got to do 15 times 3.55. I'm going to actually use that whole number I had earlier. So I'm going to multiply that by times 15, and then I'll round that off. That's only 2 significant digits right there. So 2 would be 53. So the volume is going to be, see that again, it's 53.28, but you can't, all these numbers are really unknown. The only one we know for sure is the 3, actually, and it's even an estimate. So that volume is 53. Nope, that mass, I'm sorry, that mass is 53 grams. 53 grams. All right, there we go. A couple sample problems using graphs and density.